Okay, so we want to look at a model with two factors, where one of the factors is specific to an industry. So that one is going to be perfectly immobile. And the other factor is going to be perfectly mobile. This one can move from one industry to another industry. To make it a little bit clearer, let's suppose we have capital and labor. Those are the two factors. And let's assume that capital is always specific, but labor can move from one industry to the next. Suppose we have these two industries, pizza and soda. So what we have here is we'll have some capital that is specific to the pizza industry, like ovens. And we'll have some capital that is specific to the soda industry, some kind of bottling machine. But workers can go between the two industries, wherever they're needed. Wherever they make a higher wage, that's where they will go. All right, so when you have two factors and some factors are mobile, other factors are specific, that's going to have really interesting and important implications for the income distribution when we change trade policy. So that's what we're going to be looking at on Tuesday. But today, I just want to talk about some of these concepts that we need to understand in order to understand and be able to work with the model. So the first thing, the first concept that we need to understand is production functions. A production function shows the maximum amount of output that can be produced in an industry given your resources and given your technology. So if this was the pizza industry, the maximum amount of pizza you can produce will depend on some function which in turn depends on how many machines, how much capital do you have in the pizza industry, and how many workers do you have in that industry. This functional form, this F here, that's what shows us technology. So we have technology, a fixed factor, and a mobile factor, which determines how much output we can get in the pizza industry. And if you look at the soda industry, there's a function that depends on the amount of capital in the soda industry and the number of workers in the soda industry. To trace out a production function, since technology is fixed and capital is fixed, the only thing we can change is the amount of labor. So therefore, we would increase more and more workers, and then we'll see what happens to output. The reason output is going to have this shape is concept number 2. The law of diminishing returns, or the law of diminishing marginal product. The law of diminishing returns says that when you add more of a mobile factor to a fixed factor, output is going to increase at a decreasing rate. So that means that the marginal product of labor decreases as the units of labor increases given your fixed amount of capital. If you're okay with the law of diminishing returns, everyone, then I just want to make sure you are okay with concept number 3, which is the slope of the production function. The slope of the production function is going to be given by the change, as if we look at the pizza industry, for example, the change in pizza as you change the number of workers in the pizza industry. If you added one more worker, so if this was 1, then there will be an increase in output. And that increase in output, that extra amount of output you get from adding one more worker, is what the marginal product of labor in the pizza industry defines. If you like to work with unit labor requirements instead, then that would be equal to 1 divided by the unit labor requirement in the pizza industry. And if you added a worker to the soda industry, increase in output will be equal to the marginal product of labor in the soda industry. All right, if you are okay with that, then I will erase everything. And let me draw the 2 production functions. So now we have one production function for the pizza industry. And because of diminishing returns, it looks like this. And we have one production function for the soda industry, and that one is also subject to diminishing returns. So that one looks like this. And you can see that the slope, like if you picked any amount of labor, the slope at this point is giving us the marginal product of labor in that industry. And you can also see that if we added more workers to the pizza industry, the slope becomes flatter. So the marginal product of labor decreases as we add more and more units of labor to the fixed amount of capital. So you have more and more workers working the same amount of machines, which makes each worker less productive. All right. Can you also see here that the amount of output that we have in the pizza industry and the soda industry is completely determined by how many workers are working in each of the 2 industries? You're nodding, okay? This classroom has never been this quiet. So obviously a worker cannot work in the pizza industry at the same time as he or she is working in the soda industry. So what we have now is concept number 4, which is all about a labor constraint. So whatever the fixed amount of labor we have in this economy, they will either be in the pizza industry or they will be in the soda industry. But a particular worker cannot be in both industries at the same time. We can put this, if you just wanted to draw that, we can put the number of workers in the pizza industry and the number of workers in the soda industry on the 2 axes. And you'll have this 45-degree line, which shows that as you add more workers to the pizza industry, you're going to have to take workers out of the soda industry, because that's the only place where we have workers that can be going into the pizza industry. All right, so now we have We have a labor constraint, we have a production function for the pizza industry, and we have a production function for the soda industry. And what I want to do is just put all those three things together. So you understood those three diagrams. Now I'm just going to be flipping them over and rotating them a little bit. So if we had our labor constraint, but let me put it kind of upside down. You still with me? And then I'm going to draw my production function for pizza right on top of the labor in the pizza industry axis. And because of our diminishing returns, we're going to have a production function that looks something like this. And I'm going to draw my production function in the soda industry so that its labor axis lies on top of the other labor axis. And because of diminishing returns, the production function is going to look something like this. Now we see that we have one quadrant where the axis is in pizza output and soda output, that we might be able to figure out how much soda and pizza can this economy produce given its technology, which is fixed, given its capital, which is specific to each industry, and given how many workers are working in each industry. So we'll do a few things here. Suppose all the workers are in the pizza industry. Then obviously we will have pizza, but soda production is going to be zero. There's nobody working the soda machines. All right, so that point is going to be right here. If you want to figure out how many units of pizza is being produced, you go up to the production function, and then you go right over here to read off what the production possibility is if all the workers are in the pizza industry. Let's call that point number one. Here's what if all the workers are in the soda industry. Then we're going to have soda, but we're not going to have any pizza. If all the workers are in the soda industry, we're going to be right here. We can figure out how many units of soda we can produce in that state of resource allocation. And that will be another point of possibility. And then, of course, I can just assume that there are some workers, say, in the soda industry, there are some workers in the pizza industry, say, right here. So here's LP3. And if there's that many workers in the pizza industry, you can only have this many workers in the soda industry. So here's BLS3. And we remember that output in these two industries are completely determined by the amount of workers in the two industries. So once you know how many workers are in the pizza industry, you can go up and figure out how much pizza will be produced. And you can do the same thing for the soda workers in the soda industry. And that many sodas and that many pizzas is another possibility that this economy could be producing. Just to really do this one to death. Suppose we had another allocation of labor. Suppose we had fewer workers in the pizza industry, which will allow more workers in the soda industry. So now we have a new point on the labor constraint that's different from the previous one. Again, the allocation of labor completely determines output, so we can go up and see how many units of pizza is being produced and how many units of soda are being produced. And of course, you can see that I could just keep doing this, just move workers from one industry to the next one, figure out how much output they're producing, and then I could trace out a curve that will look something like this. That curve is tracing out our concept number 5, which is the production possibilities frontier, the PPF. You look at this red curve and you see that each point shows a combination of soda and pizza that this economy can produce given its technology, its capital, and its labor resource. So we have a combination of two goods that can be produced given resources and technology, and that's the definition of a PPF right there. If you feel good about that one. Let's look at the slope of the production possibilities frontier. Clearly, the slope of the PPF is changing as we change the amount of output that we're producing. So we have the production functions are concave, and therefore the PPF is also concave, which means that as we produce more and more soda, something happens to the amount of pizza that we have to give up. So you already know that the slope of the PPF is the opportunity cost, but let's think about it a little bit more carefully. So the slope of PPF is equal to the rise over run. Rise over run gives us the slope. We know this is going to be equal to the opportunity cost of soda, but let's think about it a little bit so we understand it a little bit better. All right, so opportunity cost is all about how many units of pizza do you have to give up to get one soda. So let's think about that. The only way to produce more soda, what would you have to do in order to produce more soda in this model? Somebody tell me. You have to give up pizza, but what exactly would you have to do? You have to add more labor to the soda industry. And where are those workers going to come from? From the pizza industry. So The only way to add more soda is to move workers from the pizza industry to the soda industry. As we add more S workers, there's going to be a change in the output of the S industry. But we know what this is equal to. The change in output when you change labor, that's the marginal product of labor in the S industry. Is that going to increase or decrease? Well, the marginal product of labor is going to be a positive number, so there's going to be an increase in output in this industry. But there's also going to be a change in the pizza industry because we're taking workers away from them, and if there's not enough workers or not as many workers, then we won't have as many pizza being produced either. And when you take one worker out of the pizza industry, what you lose is how productive that last worker was. So that's the marginal product of labor in the pizza industry. Let me just rewrite that a little bit. So we have that the change in pizza was equal to the marginal product of labor in the pizza industry. And the change in soda was equal to the marginal product of labor in the soda industry. So therefore, the slope of the PPF is equal to the ratio of the marginal product of labor in the two industries. And what this says is that in order to increase output in the soda industry, you have to take workers away from the pizza industry, and therefore there will be a decrease in output in the pizza industry. And this is what we call the marginal rate of transformation, or maybe you call it marginal rate of technical substitution. And the marginal rate of technical substitution is the slope of the PPF, which shows us an opportunity cost. Again, how many pizzas do you have to give up to produce one more soda? The marginal rate of transformation, the marginal rate of technical substitution. You doing good? This is actually pretty much it, but since we have a few minutes, maybe I can just do one more thing. Where in the PPF are you going to be? So we have this picture shows how much we can produce. The question is, how much will we produce of the two goods? So right now we're working in a perfect world. In particular, we have perfect competition. In a perfectly competitive world, where all markets are perfectly competitive, we know that a worker in the pizza industry is going to be paid the value of her marginal product. And we also know that the worker in the soda industry is going to be paid her value of her marginal product. Since we have perfect factor mobility in terms of labor, that is, we have national labor markets here, a worker can move to any industry that he or she wants to work in. And of course, a worker would like to work in an industry where she can make the most money. So the supply of labor across the two industries will allocate itself until the wage rate in the two industries are exactly the same. That's how we determine the allocation of labor. That will be this point over here, how that is determined. But now we see that the wage rate in both industries is going to be equal to the value of marginal product in each industry, because they're both equal to the wage rate, and the wage rate is equal to each other. And now you can see that one could easily just kind of play around with this one. In particular, if I just rearrange just the things on the other side of the equality sign over here, we get that the ratio of the marginal products is equal to the ratio of the prices, or the marginal rate of technical substitution is equal to the relative price. Or, this is how we talked about it before, the opportunity cost is equal to the relative price. Now, if I were to give you a relative price, suppose I gave you a relative price like this, you can see that this economy would produce where the relative price is equal to the marginal rate of transformation or technical substitution. In order to produce these output levels, they would have to have this many workers in the pizza industry and this many workers in the soda industry. And that would explain everything in this economy. But suppose something happened. Suppose, for example, that we open up for international trade. When you open up for international trade, your domestic relative price will be different from the terms of trade. So, for example, if the terms of trade was equal to this relative price instead, you can see that this economy would decide to produce more pizza and less soda. In order to do so, they're going to have to move workers into the pizza industry and out of the soda industry. You can also see that as we add more and more workers to the pizza industry, the marginal product of labor in the pizza industry is going to decrease. But the marginal product of labor in the soda industry is going to increase. That is going to create income distributional effects. Some workers will be better off or worse off. At the same time, by the law of diminishing returns, if you have more workers working the same amount of capital, because capital is fixed here, if you have more workers working the same amount of capital, you can see that the marginal product of capital is going to increase. Capital becomes more productive if there are more workers working it. So the marginal product of capital in the pizza industry is going to go up. But if you have fewer workers working the capital in the soda industry, the marginal product of capital in the soda industry is going to go down. If I ask you, if this happened, if you own capital, where would you like to own capital? In the pizza industry or in the soda industry? Remember, with a competitive market, the real return to any factor is equal to its marginal product. So the real return to a capital owner in the pizza industry will go up. This one's a little tricky. because it looks like it should go down when you look at the diagram. But this is the labor, this shows the marginal product of labor, not the marginal product of capital. So therefore, capital owners in the pizza industry, the export industry, is going to be better off. Capital owners in the soda industry, the import competing industry, will be worse off because the marginal product of capital goes down in that industry. All right, so that's what we're going to be working on a little bit later.